Okay, guys, we are here at the last lesson, Unit 4, Lesson 4. So, when I did the last few lessons, I showed the quadrilateral hierarchy like a family tree. If you watched the last Edpuzzle, the Unit 4, Lesson 3 one, you saw it kind of breaking down like this. And I made a really awkward analogy about cousins getting married and having kids or something. So we're going to forget about that. I saw this breakdown. I kind of liked this better. If you liked the little family tree version that I had in the last video, you can use that one. But I kind of like this because it makes it easier to answer these questions. What we have here is kind of a pie chart or a Venn diagram more, not a pie chart, a Venn diagram of how the traits break down for these shapes. Everything on the inside is a quadrilateral, right? Quadrilateral is the big circle. All of these things are quadrilaterals because they have 4 sides. Within quadrilaterals, we have parallelograms. Parallelograms is the next circle that is within the kind of umbrella of quadrilaterals. So all parallelograms are also quadrilaterals because the entire circle is within quadrilaterals. Within parallelograms, though, we have rectangles and rhombuses as well. You guys should know how Venn diagrams work. What this kind of means here is some rectangles are also squares, and some rhombuses are also squares. And a square is both a rectangle and a rhombus because they have those traits. They share those traits. A square has all of the traits of a rectangle and a rhombus. That's why it's in that overlap section, because a square has all of the traits of both of those things. Now, what this means, though, is that there are some parallelograms that are just plain old parallelograms. They're not a rectangle, they're not a square, they're not a rhombus. They're just a plain old parallelogram. There are some rhombuses that are just plain old rhombuses and not a square, right? We have part of this circle here that is not a part of square. So that's what we're going to be looking at today, is when a certain shape is always, sometimes, or never another shape. And it's based on this hierarchy. We're going to keep looking back to it. So here's how you know, and you might want to copy these down. Get my camera out of the way here. So the question is this, they're going to give you a statement. We need to say if it's always, sometimes, or never true. Now, a statement is always true, if the first shape referenced is entirely inside the second shape referenced. So, for example, looking here, a rhombus is always a parallelogram because the entire circle for a rhombus, this is the entire circle for a rhombus, that is entirely inside parallelogram. So yes, it is always true that a rhombus is always also a parallelogram. Now, it is sometimes true if the first shape reference is only partly inside the second shape reference. So if we flip-flop this and we said a parallelogram, that's now the first shape, is a rhombus. We want to say if that was always or sometimes or never true. Well, here's parallelogram. Only part of a parallelogram is made up by rhombus. So this would be sometimes true. A parallelogram is a rhombus is only sometimes true because we have all of this space here that is not rhombus. So sometimes it's true. We've got this space that is a rhombus, but sometimes it's not. Now, we would have never if the first shape reference is not at all a part of the second shape, or if the statement is just not true. We're going to look at some of the properties that are going to say a rectangle has 4 congruent sides. And you need to say if that is sometimes, never, or always true. It might not be a true ever if that property is not a part of that shape. So these are just little tricks we can do. It gets kind of confusing here to keep this straight, but our answer will always be, we're going to do 5 examples, always, sometimes, or never. Let's look at what we mean here, though. So this first example here, a rectangle is a parallelogram. So this is the first shape. Why did I spell out first? This is the second. So it is always true if the first shape is completely inside the second shape. It is sometimes true if the first is only partly inside the second shape, and it is never true if those circles don't overlap at all. So let's look to our picture here. Rectangle comes first, parallelograms come second. Is the rectangle entirely inside parallelogram? Yes. Here's all of rectangle. It is entirely inside parallelogram. So the first shape is entirely inside the second shape. Our answer is going to be, this is always true. A rectangle is always a parallelogram. And that makes sense because a rectangle always has opposite sides parallel, opposite sides parallel, and that's what makes it a parallelogram too. So this is always true. Let's look at the second one. Here's our first shape, here's our second shape. I'm going to go ahead. We have parallelogram is a rhombus. We need to say always, sometimes, or never. So parallelogram is my first, rhombus is my second. Is my first shape, now this is confusing, is my first shape entirely inside my second? No. A part of it is, this part of my first shape has rhombus, but there's all this space out here that is not rhombus. So, excuse me, sorry. This is sometimes true. All of parallelogram is not inside rhombus, just a little circle there, but there's all this space outside that is not rhombus. So this is sometimes. Let's keep trying. So the next one, a rhombus is a rectangle. This is my first shape. This is my second shape. So here's my first shape. Here's my second one. This is my second again. This is my first. Is my first shape entirely inside my second shape? Only a part of it inside, or not inside at all? A part of it is. Here's my first shape. I'm bad at this. This part of it overlaps with rectangle. Now again, it's only a part of rhombus is inside my second shape, is inside rectangle. So is this going to be always, sometimes, or never, since only a part of rhombus overlaps with rectangle? Sometimes. Because, again, only a part of rhombus was inside rectangle, a part of my first shape was inside my second shape. This is why this is sometimes. If it's a part, sometimes. Now we have D. Now this one looks different. A square has perpendicular diagonals. What you need to do first is you need to look at and see on your property list, is this in squares properties? If that's the case, then it's always. If that property is on square, our answer is always. So let's check that first. I'm going to pull it up. Let's see. It's here. Let's look at square. Do we see the diagonals are perpendicular? Yes, we do, right here, perpendicular diagonals. So since this is a property of squares, our answer is always. It's listed under squares properties, so that is always true. This is always a true statement. Let's try another one, though. So now we have a parallelogram has congruent diagonals. Let's go ahead and let's look at, I pulled up the WebEx there, click on the wrong link. Let's look at parallelogram. Do we have congruent diagonals listed as a property? No, we don't. However, let's see where it is listed. Do we have congruent diagonals listed here on a rhombus? Nope, we don't. We don't have congruent diagonals here. Let's check rectangle. Do we have congruent diagonals listed here? Yes, we do. In a rectangle, diagonals are congruent. So what this is saying is, let me come back here again. Sheesh. In a rectangle, we do have congruent diagonals. So this is our first shape. Rectangle is our second shape. That's what this is now. So does a parallelogram have this rectangle property? Always, sometimes, or never? Well, let's look to our picture. Parallelogram is my first shape. Rectangle is my second shape. Is all of my first shape inside rectangle? Nope, but part of it is. This part of parallelogram is inside the rectangle circle, so this would be a sometimes. If my parallelogram also happens to be a rectangle, then yeah, this would be true. But it's not true for all parallelograms, just some of them. Let's try this last one. A rectangle has exactly one pair of opposite sides parallel. Now to start with, exactly one pair means that we don't have both opposite pairs parallel. This means it's not a parallelogram. A parallelogram has to have opposite sides parallel, both pairs. Only one pair means just these sides, not necessarily these ones. This cannot be true. If we look at the rectangle properties, I keep going back here. Where does it say? Both pairs of opposite sides are parallel. Not just one pair, but both pairs. So this has to be never. That is never true because we have to have both sides parallel. So I know this is a little confusing, guys. Hopefully this helps. The more you practice these ones, the easier they get, and you only have 3 options. Always, sometimes, or never. If we can narrow it down to at least 1 or 2, then we got a better chance of getting